coming! It's coming! It's coming!
Oh, there it is.
Umbilical cord. Scissors.
My name is...
Archimedes,
I was born in Sicily.
287 BC.
That little guy's me. I'm standing there with my parents and my sister Francesca in front of our old house. I don't really remember too much about the old country, except that we were pretty hard up. And then one day my father decided it was time to move away. Away from Sicily, across the ocean, to start a new life.
In Alexander, Egypt.
$27 or $100? That's a fail. We don't accept students who can't pass.
Try my best, sir. I mean, it's hard stuff. I promise I'll do better.
The discovery of pi. Archimedes started by inscribing polygons in a circle. He realized that as he increased the number of sides, it resembled more of a circle. Once he was satisfied, he put a triangle in the polygon with a base of A, a height of C, and a hypotenuse of 1/2. Then, using basic trig, he was able to calculate that sine theta equals 2a. This is important because if you look back at the polygon, you will notice that the length of a side is equal to 2a. Therefore, sine theta equals side length. Archimedes knew that the perimeter of a polygon is equal to n, the number of sides, multiplied by the length of the sides. Now, using sine theta equals side length, he could create the formula perimeter equals n times sine theta. Lastly, he found that theta is equal to 360 degrees divided by n, the number of sides, multiplied by 1/2, because the angle theta bisects the side length. His final equation was that the perimeter equals n times sine of 180 divided by n. This equation is useful because as we increase n, the number of sides, we increase the proximity of pi.
Now what if we make n equal 1/infinity? Which equals approximately 3.14159265358977932238246975028974169237816406286208 998628032482534211808. That's all I can do. That's all I can do.
Eureka! Eureka! Oh, Kirsten's home! Kirsten! Eureka! 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 Eureka!
My principle states that the volume of water displaced in a closed container is equal to the volume of the object placed in the container. I will now show you by placing this object inside the water. Well, we'll try that one more time with a different phone. It's worth another shot, so let's try it with one more. This is my principle.
The area under a curve. Archimedes started with a parabola and a line intersecting on a Cartesian plane. First, he inscribed a triangle in the area he was looking to calculate. Then, he drew smaller triangles to fill the missing space. Archimedes did this by figuring out the midpoint of the line and then going vertically down to the parabola. This point became the point of the new triangle. He repeated this many times. He figured out a pattern. If you made the area of the original triangle x, the area of each second triangle equals 1/8x. Then the area of the third triangles equal 1/64, and so on. This created a geometric series with a common ratio of 1/4 and a first term of 1. Therefore, the sum of the series is equal to 4/3. This means that the area of the original triangle multiplied by 4/3 equals the area under the curve.
Archimedes is the name, rhyming is the game. These bars are fine, I'm ahead of my time. Modern calculus would be nothing without I. After all, it was me who invented pi. 17 centuries later, Newton figured it out. The quadrature of my parabola is what they're talking about. They wanted the area under a semicircle. I figured that shit out after drinking some purple. Start with the triangle, triple it to 3, then I go ahead and label it ABC. Keep making more triangles on and on. The girls walk in and ask why it lasts so long. Add up the triangles, what do you get? The area under the curve. It's lit. Pure genius, that's why the Romans be attacking. When they come to my house, I'll be lit packing. My heat ray is killer. I did the Romans what Drake did to Milla. I'm stacking girls on girls with these old-fashioned curls. I started this hair game, now I just bask in fame. Calculus.